In this section, we will be working with function notation. Many times when you see a function or work with functions, they will be given in this special notation. And function notation is nice. This, what we have up here at the top of the page, is a very general example of function notation. What you will see first is the function name. Now, the name is usually a letter. Here I have F for function. It could be a short word or phrase, but the name of the function is given whenever you're looking at function notation. Then after that, inside the parentheses, you will have the input value or variable. The input is always going to be given inside of the parentheses, then the equal sign, and the output. Now the output could be given as a value. If you have the input value, then you'll have the corresponding output value. It may also be a formula from which includes the input variable, and you can, given an input value, evaluate the output using that formula. But this is just the general function notation. This is what you're going to see. So example 1, we have the function v of m represents the value of an investment in thousands of dollars after m months. Explain the meaning of v of 36 equals 17.4. So looking at this, v is the name of the function, m is the input variable. So reading through this problem, the input in this case, m, is the number of months. The output is the value of the investment in thousands of dollars. So what we need to do is interpret the meaning of this statement right here. I'm just going to copy it down over here at the right. V of 36 equals 17.4. Now this is given in function notation. V is the name of the function, so 36 is the input value. So 36 is going to be the number of months. So 36 months. 17.4 is the output. So 17.4 is the value of the investment measured in thousands of dollars. So 17.4 thousand dollars. Interpreting this in a complete sentence, after 36 months or 3 years, the value of the investment will be $17.4 thousand. I'm just going to write that in standard form here, $17,400. In example 2, function notation is a way of writing an ordered pair. It gives you the same information plus more. It gives you the name of the function and the knowledge that what you're dealing with is a function. But you need to be able to work from one representation to the other. If you recall, an ordered pair has the input value first, then the output value. Function notation, you have the function name. The input is always inside the parentheses. The output is out on the other side of the equal sign. So just as an example, if you have the ordered pair 2, 3, 2 is the input, 3 is the output. That is the same information given by f of 2. 2 is inside the parentheses, so it is the input, equals 3. 3 is the output because it's out on the other side of the equal sign. Moving down to the next row, we have -4, 6 as an ordered pair. Because it comes first, we know that the -4 is the input. The 6 is the output. So in function notation, the input value always goes inside the parentheses, so the -4 is inside the parentheses. the 6 on the other side of the equal sign. So we have f of negative 4 is equal to 6. In the third row, we're given the function notation. Here the 5 is inside the parentheses, so we know it is the input. Negative 1 is the output. So as an ordered pair, input goes first, output goes second. So we have the ordered pair 5, negative 1. In example 3, we're given a function k, which is represented by a set of ordered pairs, 2, negative 4, 5, 7, 8, 0, and 11, 23. And we're asked, in this first question, we're asked if k of 5 is equal to, and we're asked to find the output values. So we're looking for the ordered pair that has a 5 as the input value. And that occurs right here. When the input is 5, the output is 7, so k of 5 is equal to 7. Over here on the right, k of what is equal to 0. Here 0 is an output. So we are looking for an ordered pair that has an output of 0. That occurs in the ordered pair 8, 0. When the input is 8, the output is 0, so k of 8 is equal to 0. In example 4, we have a table of values. And the same types of questions as in example 3. Here we have b of 12. Here 12 is inside parentheses, so we know it is an input value. So in the table, we want to look for an input of 12. In the table, we have t in the top row, b of t in the bottom row. So the top row is the inputs. The bottom row are the output values. So we're looking for the input of 12. That occurs right here. The input of 12, the output is 50. Next question, b of t is equal to 18 when t is equal to 31. Here, 18 is the output value. So we're looking in the bottom row for an output of 18. That occurs right here. The output is 18 when the input is 31, so b of t equals 18 when t equals 31. In example 5, we have a graph. The graph of g of x is shown, and you're asked to answer these same sorts of questions. So first of all, g of 2. 2 is an input because it is inside the parentheses. We're looking for the output. Now, if you think of this as an ordered pair, we are given the input value. We're asked for the output value. So looking at the graph, you're looking for the point at which the input is 2. So locate 2 on the horizontal axis, go up to the graph. The ordered pair on the graph is 2, 3. So returning to the function notation, the ordered pair 2, 3, we have g of 2 is equal to 3. In this next question, we have g of what is equal to 2. So for this ordered pair, the 2 is the output. And we're looking for the input values. So on the graph, we're looking for the point that has an output value of 2. So this time we're looking for 2 on the vertical axis. Go over to the graph. You're going to move to the right. The corresponding input value is 4. On the graph, you have the ordered pair 4, 2. So function notation, g of 4 is equal to 2. Next question, we have g of 0. 0, because it's inside the parentheses, is an input value. So we've got the ordered pair 0, and we need to find the output values. So locate 0 on the graph, and we're looking for the output values, so go up until you hit the graph. The ordered pair on the graph is 0, 4. So g of 0 is equal to 4. Now we have G of what is equal to 1. The 1 is an output value, so we've got the ordered pair something 1. We need to find the input value. So on the graph, look on the vertical axis for positive 1. Go over to the graph. The point on the graph is the ordered pair 6, 1. So G of 6 is equal to 1.